In this video, I'll be going over integrating even and odd functions. So recall how we can determine whether a function is even or odd. A function is even if f of x equals f of negative x. A function is odd if negative of f of x, or negating the function, equals f of negative x. So some examples of even functions might be x squared, x to the fourth. Cosine is an even function. Secant is also an even function. So functions are odd, like x cubed, 1 over x. Tangent of x is an odd function. Sine is an odd function. Okay, so a function is even, or an even function I should say. The graph will be symmetrical about the y-axis. So x squared is symmetrical about the y-axis. An odd function we say is symmetrical about the origin. So x cubed is like this, and the origin is just the line y equals x. So see if I can kind of show that this is symmetrical about that line, y equals x. Okay, so that's just a recap. So what does this have to do with integrals? All right, so if we have a function f of x that is even, and we're integrating that between negative a and positive a. So that just means we're integrating between an equal distance from 0 on the negative, to the left of 0 and to the right of 0. So a shortcut here to evaluate this is going to be 2 times the integral from 0 to a of f of x dx. Now why does this make sense? So suppose f of x, again, is x squared. Okay, so suppose that's our function, and we are integrating this between negative a and a. So what we can see here is that these two areas are equal, okay, and with 0 in the middle. So what we could do is we could just evaluate this portion right here and multiply it by 2. So we could just integrate from 0 to a, multiply that by 2, and that'll give us the value of that definite integral. And we need to be careful. We need to make sure that these two values are just opposites of each other, and then this rule will apply. Okay, and then let's talk about if a function is odd. I'll just write it down here. Okay, so if a function is odd and we're evaluating it from negative a to positive a, that definite integral is just going to be equal to 0. And let's see how this makes sense. If I have some odd function like this, and suppose I'm evaluating it from negative a to positive a, those areas are going to be here and here. So one of those areas, the area below the x-axis, will be negative, and then the area above the x-axis will be positive. So they'll cancel each other out. So if we have an odd function and the limits of integration are just opposites of each other, that definite integral will equal 0. So let's look at an example of each instance here. The first one, we have the integral from negative 2 to 2 of 3x to the 8th minus 2. I'm just going to verify that this is actually an even function, just as a little algebra review for us. So I need to show that f of x is equal to f of negative x. So f of x is just 3x to the 8th minus 2, and then 3 times negative x raised to the 8th minus 2. And on the right-hand side, we get 3. Negative x to an even power just becomes positive. So we do see, in fact, that this is even. So because this is even, I'm going to rewrite this integral from 0 to 2, well, I should say 2 times the integral from 0 to 2 of 3x to the 8th minus 2 dx. And the reason we want to do this is because it's really easy to evaluate an integral if one of the bounds is 0, which is what we have down here. So evaluating this integral, we're going to have 2 times, let's see, 3x to the 9th divided by 9 minus 2x. We're going to evaluate that from 0 to 2. So I have 2 times 2 to the 9th power is 512 divided by 9 minus 4. Okay, so inputting 2 in there, I get that, and then this is why we want to use the 0, because when I input 0, I just end up with 0 here. And let me just write it like this. Okay, so I could put a 2 in both positions like this, or we could say use another set of grouping symbols and just multiply by 2 at the end. So evaluating this expression, we're going to have 512 over 3 minus 4 times 2, and we end up with 1000 over 3. Okay, so that's the value of that definite integral. Give me 1 sec. Oh no. So again, why does this make sense? Well, if I look at the graph of negative sine of x from negative pi to pi, and we just compare these areas, the area on the left here is below the x-axis, so it'll be negative. Then I have the same size area here, but it's above the x-axis, so it's positive. So I have a negative area and a positive area that are the same size. So the integral is equal to 0 here.